Manganese, as a titanium, is one of those pigments that plays a pivotal role in art, in pigments, but basically just because of one pigment, the umber. Raw umber, burnt umber. Umber main component is this one, manganese dioxide. So one atom manganese, two atom oxygen. This mineral, pyrolusite, has been used from prehistory to obtain that kind of brown color. It's never pure, it's always mixed with iron oxides, but we distinguish umber from the sienna earth pigments because of the content, specific content of manganese. Manganese 25, and these are the X lines. So we have the K alpha is at 5.9 and the K beta is at 6.5 keV. We start our examination. As usual, we want to have a baseline, just manganese. We have here this manganese dioxide, and the spectrum that we get from this brown powder, the base for amber, is this one. We see the strong K alpha of manganese and the K beta. The counts is very high. We are in order of 130,000 counts, very high, and we are using the low keV filter set for this examination of the low keV elements. Let's examine now actually the raw amber, so in the pigment checker standard version. The signal we get is the red one. Over here we see the peak of manganese will be around 5,000 counts. Compare it with pure manganese dioxide, and then here is the actual pigments, raw amber. We see that the peak of manganese is much less. And we see this other peak over here. This peak, you see the position is not a 6.5, that of the K beta of manganese, but is a 6.4. This one is iron, the K alpha line of iron, because raw amber pigments is a mixture with iron oxide and manganese oxide. The content of iron is very abundant, is a lot of it, so it's the main component, but there is also manganese that gives the specific brownish, dark brown color. Now we analyzed burnt amber, that is basically the calcinated raw amber, and this calcination is done in order to get a darker tone to the amber. Nothing changed basically in terms of the XRF spectrum, so you see basically we see the manganese here, the iron peaks over here, and this one is the other iron peak. Other than amber, there aren't pigments that have been used that much in art as pigments. We have manganese ammonium pyrophosphate, so this compound here. This one is called manganese violet, and it is in a pigment checker standard. This pigment was commercialized by Winsor & Newton in 1890, but used sparingly because it didn't have a strong hiding power. Manganese violet, the spectrum is over here, so we see the K alpha of manganese. We see a lot of it because there is just manganese basically. You see from the formula, the only element that is relevant for XRF is manganese. Then we have phosphate, oxygen, nitrogen, hydrogen. So those don't play a big role. We see a lot of manganese over here. The other pigment we want to test is manganese blue. It's a barium sulfate permanganate. Basically we have manganese and barium. This was considered the best blue, but eventually has been discontinued in the 90s of the last century. The spectrum that we get, of course, is this one. So you see, in this case we see less manganese and we see the barium peak over here.